probably people coming in because if you haven't used Zoom in a while, it requires you to download the app and then you can get in. You can't enter just the meeting ID and passcode anymore. And hierarchy of control is covered because it's on every test. And if we take a look at some of the domains, they'll say you have to have knowledge of the hierarchy of hazard controls, and it's in all the major tests. And one of the things that we'll do is do knowledge checks. I don't use the exact question. I rewrite the question. Exam Core from BCSP gives you the exact question, but I have to rewrite them. So same kind of knowledge, because if you got the hierarchy of controls, there's only so many answers that are possible. So the chart you see on the right, or the diagram, is what we see all the time, and it comes from the 1950s. Elimination is the most effective control, then substitution, engineering controls, administrative, and personal protective equipment. A lot of other groups have sat there and made different hierarchy of controls, but this is what's going to be on the test. And so it sounds so simple, except when they give you examples and they ask you which one is this, you'll see from the knowledge checks it's not so easy. So let's just go into first knowledge check. We can type the answer into the chat. The section in hierarchy of controls which affords the worker the greatest level of protection is A, engineering controls, B, administrative controls, C, personal protective equipment, D, elimination. Excellent. The answer is D. So it started in the National Safety Council, known as a hierarchy of controls. The idea was to try to control the hazards as a priority. When you have a choice of different solutions, choose the one that is more safe and more effective. Before that was trial and error. So we got to go into the mines and we have to figure out if there's toxic gases. They would literally bring a canary to take this bird in there, and if the canary started getting sick or listless, that indicated some bad gas. And is that elimination of the hazards? No. It's just trying to detect it, and then they would have to try to figure out what they're going to do. With these toxic gases, they didn't really have effective respirators back then. So they would try to put some ventilation in. And we'll talk about ventilation as one of the control methods. So which is the best preferred method in the hierarchy of controls? Now this one, a little bit different style of question. Personal protective equipment, A. B, substitution of less hazardous materials. C, engineering controls. D, elimination of the hazard. And the answer is D, elimination again. One of the things that they often do is they leave out elimination out of the 5 different things, and then you have to know what's after elimination. So elimination, we're physically removing the hazard, and that's the difference. So when we take about, we have to change a light bulb, we have a hazard of a fall from a ladder. And we know from statistics, roofs and ladders are the number 1 and 2 things that people fall from. And for ladders, step ladders are the number 1 source of injuries. So we can use an extension pole to take the bulb out, and then we don't have to get up there and fall at all because we're standing on the ground using an extension pole. And that's an example of elimination. And you'll get examples talking about this is what we're going to do is it one of these 5 methods, and you'll have to be able to catch that. Here we're going to go up on top of the tank. We have a ladder that's provided with cages. Now cages are not fall protection by OSHA. They're just something they came up with in the 50s. OSHA wants positive fall protection. Offset the platform every 30 feet. And if you're climbing a fixed ladder at 24 feet, they require something to be protecting the worker, usually like a ladder safety device. But we can sit there if we need to inspect it. We could use a drone like in the middle picture. 8 years ago, I was using drones to inspect areas on the roof. And we could see that they set up the warning lines way too close. If you're a roofer, they have to be at least 6 feet from the edge. Or we can put security cameras where we can just watch the roof from a series of cameras. We don't need to go up there anymore to check on it. So that's an example. A lot of times security people were going up on different places to see if people were trying to enter the roof and things like that. Now we have cameras. Substitution is lightly less. We're going to replace a hazardous with a safer alternative, hazardous chemical with a safer alternative. So when you would buy this chemical called Zip Strip, it contained methylene chloride. And methylene chloride is a known cancer. But when you would get the data sheet, it would say carcinogenicity explanation. Methylene chloride is listed on the IARC and NTP carcinogens list. A lot of people did not know carcinogenicity is cancer, and that's one of the things that you have to know, because you never know if that'll be on a test. But IARC, International Agency of Research on Cancer, and National Toxicologic Program. These are the two independent nonprofits that look at the chemicals, and they decide based on the data and the research that that chemical could possibly cause cancer. For example, some of the wood dust are considered to be cancerous. Welding fume is considered to be cancerous. So you have to, even though OSHA has not, adopted those as cancer-causing areas, you would need to have those as something you'd want to try to substitute out if you can. So they make what they call, non-methylene chloride cleaners or paint strippers, and those was what you want to use. So another knowledge check, and we're going to have a series of these because this is how people learn. Within the hierarchy of control, administrative controls are considered to be which of the following? Now this is a tough question. This style of question comes up a lot. More proactive than elimination, less proactive than substitution, more proactive than engineering controls, less proactive than the supply of PPE. So type in the chat what you think the answer is. So proactive, better. If I just used the word better than elimination. This is a tough question. Very good, it is B. Remember, substitution is before administrative controls in the hierarchy. So a lot of people, when they see this, they freeze because they don't realize what the proactive means, and it just means better, And it's a tough question. So substitution, a lot of people would say, well, this could be elimination, and this is where it gets very tough. If we got excessive noise using a gasoline power chainsaw, like on the left, when you look at the little noise chart, 110 plus decibels. By OSHA's rules, you can have no more than 115, and 110 means you get about less than an hour of exposure, probably like 30 minutes at most. And so today you can buy battery-powered chainsaws. So when I go out there and I measure it just on, it's about 83 to 84 decibels, below the industry standard of 85, below the industry construction standard of 90 for what they call an effective hearing conservation program. Those are typical questions they'd also ask you. When you cut, it's going to make a little bit more noise. So we didn't really eliminate the noise hazard. We just brought it down dramatically. If we were below 80 decibels, then you could say we have something that has eliminated the noise. But studies have shown that if excessive exposure to 83, 85 for 24 hours can cause hearing loss. So that's a substitution case, and that's a tougher one. So let's go into this. Which is a good choice for substitution? A, substitution of a welding rod with chromium for those that have copper. B, substitution of a paint that contains toluene for benzene. C, substitution of an adhesive containing formaldehyde for one containing isopropyl alcohol. D, substitution of a cleaner containing methylene chloride for one that has ethanol. So this one is, now you have to know the hierarchy, and then you got to know which ones can cause cancer. You're expected to know the cancer-causing chemicals. This is tough. Formaldehyde is a cancer-causing chemical, so we're going to go get a isopropyl alcohol you can put on your skin. It is a flammable, but we are getting rid of the cancer hazard. Chromium is an exposure that's a cancer-causing metal. Copper can cause serious disease, and that's one of the things. So it's not cancer-causing, but you're trading one. This is a tough question because some people say, well, copper isn't really cancer-causing. Yeah, I know you can get damage to your lungs, but isopropyl alcohol is going to probably have no damage. So that's a tougher, lesser of the products. Toluene for benzene. Now we're taking benzene in the product, which is cancerous. And then methylene chloride, again, we talked about, is cancer causing. So this is a little bit tougher question. They weight these questions now by the board. It used to be you have to have 60% to pass. Now you have to have probably at least always a 61 will pass from doing 5,000 exams and stuff. But this would be a weighted question. This would be a lot harder than what is a symbol on JHS. Engineering controls are our third level. It involves replacing equipment and processes or changing the work environment to separate and isolate the worker from the exposure to the hazard. So if we have the lathe on the bottom, we have a rotating shaft on a lathe. It cuts the wood leg for a bed or a metal or plastic or whatever you're going to use, and it rotates, and we have a rotating part. And lathes have killed, to my knowledge, about 26 people since 2000. So about a one a year somebody gets caught. Their shirt sleeve, their hair. I just watched the video yesterday when the shop teacher showed me the person's shoulder was loose, big baggier shirt got caught in the lathe and couldn't pull it out. And at least the shop teacher heard the person yelling and was able to shut it off with emergency stop. You got to have a red emergency stop on all equipment. These old machines, they didn't have it. So he just went and hit it, and then they untangled the shirt from this person. Okay, so all we do in this case, this is going to have an interlocked door. You're going to look behind the window here, and you can watch the lathe work. You open the interlocked door, it's going to shut off immediately. Usually going to have 3 items you have to do before it will actually start again. Shut the door, hit the cycle on button, hit the green on button. That's how they're doing engineering controls. So the failure of one item would not cause the machine to be running. A lot of things with noise, you can also do enclosures. They sell sound blankets and barriers. You put the device, in this case could be an air conditioning unit, behind these barriers, and then the people who are on the outside of it are not going to hear it as loud. It dampens the level of noise. The best is really concrete. If you have a 6-inch, 4-inch wall of concrete, the sound just bounces off of it, and you will not hear it on the other side. Some of the material, like wood, not so good. But this is what we call isolation of the equipment to hopefully minimize the noise. Ventilation, remember I said welding smoke is a cancer-causing fume. When you're in that cloud, you're breathing it. And the idea is that we can always wear a respirator, which is always the last choice. PPE is the last choice on the hierarchy of controls. But it's much easier to have an engineering control, such as a fume hood or a smoke hog like you see on the right. It draws the smoke away from the breathing zone. You can be a billion-dollar company, and I see workers working and the smoke's going over here. For this few $1,000s, this thing can take away all that smoke. And that's what you want to do. Welding smoke is nothing is good for you. And depending on what they're welding, it could be even worse if they're welding on stainless, because the chromium fume is a cancer-causing metal. Moving the hot works brazing, you're just melting it, and it's not going to be welding per se, but it's brazing operation from a combustible dust food environment. That means we have combustible dust in the air, to a safer, cleaner, non-ignitable environment would be an example of using what? This is tough. A, elimination. B, substitution. C, engineering controls. D, administrative controls. So we're moving the hot works brazing operation from a combustible dust food environment to a safer, non-ignitable environment would be what? This is hard as they get. The hazard is fire. Okay, the answer is elimination. What we've done is we're going to do brazing, which creates heat, and then move it to a nice area, like maybe all concrete or steel, where there's really no more fire hazard. So we have eliminated the fire hazard by taking that operation out and putting it in an area where there's no fire hazard. That's a little bit tougher. These are, when like I said, people, a lot of times when they talk about hierarchy, they just tell you these 5 and then everybody understands what it is. But when you get into some of these tests, this is a little bit tougher. So what did we do? Some people said we substituted, but we didn't substitute it. We did substitute the environment, but the environment eliminates the hazard, so it really meets the definition of elimination. That's the best answer. Machine guarding has always been an engineering control. Back in the 30s, they came up with guarding the machine. You got a belt and pulley, put a guard around it. Make sure it's fixed. I like guards like this you can see through, so if the belt is starting to fray, you can get a new belt. Interlock and barriers are common ones. A barrier guard usually is less than a 1/4 inch opening. And by making it a 1/4 inch, you can't get your fingers in there to get them cut off. The OSHA standards from the punch press standard 1910-217 talk about a 1/4 inch opening. That's where you're going to find that number. So when, if you get a question, what is an engineering control? We can put it behind a barrier with a 1/4 inch opening. They may ask you, what if it's an 1/8 inch, 1/2 inch, 1 inch? Those wouldn't be acceptable barriers for machine guarding unless the hazard is so far away from the barrier. But the interlock, we open it up. That's what an interlock looks like. It shuts off. You cannot run the machine while the interlock is engaged. What you want to do is make sure when the door shuts, it doesn't just start up again. Because you could be in there and you slam the door. So usually there's going to be 3 levels of things that have to happen before it restarts. Another complicated question. A 100,000 pound forge is used to hammer hot metal into a steel ring. Which protection is best for the 120 decibel noise? A, use 30 decibel hearing protection. B, rotate the workers every 2 hours. C, enclose the area with sound dampening material within the operator outside the enclosure. D, have the worker stand 10 feet away. These are all good, but the answer they're looking for, very good. Everybody's got C. Make sure you put the enclosure. So that's an example of an engineering control. Also, 2-hand controls are very popular on machines. I always tell people, you want an amputation, use a foot pedal. There's no reason you cannot use a machine with 2-hand controls today. You got a small part, make a fixture to hold it. Hit the 2-hand controls, you're not going to get in trouble. It's just easiest way to eliminate accidents with forming, shearing, punching machines. Which is the following is an example of an engineering control? Training employees on safety procedures. B, providing safety goggles to workers. C, installing machine guards. D, conducting regular safety inspections. The answer is C. Install the machine guards. That's an engineering control. The other ones, training is always an administrative. PPE is goggles. And regular inspections, those are administrative controls. Now we get into administrative controls. Refers to a training practice policy that or design change that reduces an individual exposure to hazard. The one that everybody understands in the United States is this safety monitoring system for flat construction roofing work. Back in the 1970s, they were at the edge of these roofs and they were falling. Remember, ladders and roofs are the #1 source of falls. And the industry came up with, we're going to use a monitor. We're going to have these flags be a guardrail height, but they're not going to be as strong as a guardrail. They'll be on cones because we're going to move them. We'll put them 6 feet away, and behind that will be the monitor watching the workers at the edge. When I started in OSHA, back in the early days, I thought this was crazy because you would have to actually watch the worker fall if you were doing it right. But what we found out is that it's a heightened sense of awareness if the monitor is watching it. It's very expensive to pay somebody to do nothing but watch. So it's a lot easier to put portable guardrails up now than it is to, do this monitor system. But that is a control. Statistically, it does lower the injury rates for companies that do use it. Safe work procedures. Everybody recognizes lockout. If you're a manufacturer, this is the #1 citation to a manufacturing company. You don't have safe procedures to lock out and put it on your machines, whether it be a conveyor or a punch press or a pasta machine. So you need a procedure for each of these machines under lockout. That's an administrative control. Training and education. You have to train people. The OSHA standards will ask you for training. There are at least 10 standards you have to train people in. Fall protection, ladder safety, scaffold safety, confined space, lockout, electrical safety, and so on. So they require you, before you put the worker in that situation, even PPE, you have to be trained and understand the use and limitations. So in confined space, they require you to do a bump test, which is a calibration gas. We're going to verify that these 4 alarms are going to work. We got alarm here, 2, right next to it is 3 and 4. By using calibration gas, we're not calibrating, we're just testing it before we use it. It goes and sets off all 4 alarms. In the industry standards under ANSI, American National Standards Institute, the confined space standard requires you to train the atmospheric tester. That's the term they're going to use. And they have to know how to do this. This is not in OSHA's rules. It's from the industry, because the industry has changed their rules several times from the 1995 industry standard. You also have to train people on how to use ladders. I run 90% of the workers have had no safety training on a ladder. Not a toolbox talk, not a training session. You got to go in there and tell them what to look for. Inspect the ladder. The #1 criteria I see is rust. And you can see this foot is rusted. This little bolt popped out, and he broke his hip, and $500,000 of injuries related to his broken hip, and putting in a new artificial hip and everything else. And it's tough. But I asked people, did you inspect the ladder? Oh yeah, they looked at it. And I said, well, this is where it broke. You didn't get the rust in 5 seconds. You should have been able to pick this up. And that's an important issue. So you have to give people training in hazard recognition for anything that they're really going to do. So which control would be the least desirable? Boy, that's a tough one. Now you have to think backwards. Substitution of a less toxic material, and closure of the operator, job rotation, or local ventilation. Very good. It is job rotation. Substitution is second. Closure of the operators and engineering control. Ventilation's in engineering control, and job rotation's administrative. So job rotation. I was at a place Thursday where they tripled the injuries this year. And one of the things that they decided to do, and it was a poultry plant, is rotate the workers. So you have people who are doing a certain job, with the birds. It's a poultry plant. They could either, be taking the insides out, or, cutting the breast out of the, the chicken. But they have to, do this. Repetitive routine work is very tough on the body. If you do the same cut 1,000 times in a day, your arms are going to fall off. So they said, we're going to rotate. Even though they had a good safety issue and they identified workers and they did it, they wanted to rotate them. And some of the things that they started doing it just didn't make sense. They're going to have this worker push this stainless steel bin that's full of chicken products out. And I started looking at this and I said, how much does that weigh? 300 pounds. It doesn't have wheels. Well, we need to get it moved to the next section so the workers can, take it and then process it for, sausage or whatever else they're going to make out of the repaired meals, as I call it. And I said, well, job rotation is not really fixing the hazard. The hazard is this thing doesn't have wheels. And then we look at the injuries. Hernia, blown knee, blown back, hundreds of thousands of dollars. And I said, well, I have a place and 2 or 3 places that do the exact same. This is all on wheels. You could push the cart with 2 fingers with 300 pounds on it. And they're like, they give you that look like you got to be kidding. And then I show them photos and they're like, Well, why? Then somebody asks, why do we have these big bins with no wheels? And you could use a forklift, but it's a lot easier if you're just going to move it like 15, 20 feet. Just put it on wheels, and I always use the 2-finger test. The maximum push-pull should be almost 35 pounds. So you can pull 35 pounds with your fingers, and if you can't do it, it's too heavy. But that's a case. They rotated. They tried to make it better, but all of a sudden we got people of all different ages trying to push this, and guess what? We don't have a lot of success. Somebody who's maybe 22 years old and lifts weights can do this all day long, but we go in there and we get a 50-year-old, 60-year-old person. They've never done this. This is going to be tough on them. So I says we got to stop. We got to fix the hazards. The rotation is not fixing the hazard. Rotation means we spread it out, but we didn't fix the hazard, which is the weight of this cart. Warning signs and labels. Now, NFPA 7E, which is the arc flash standard to protect people working with electrical. The rule of thumb is if you're within 42 inches, you better be a qualified electrician. That's a simple rule. If you just remember that, you'll go through it. They want, and by the codes, an arc flash sticker on that panel box. It's going to tell you that the arc flash boundary is going to be like 42 inches for limited approach. That means you and me would stay 42 inches back. The flash can go 24 inches from the panel box. And you're going to have to wear Category 1 PPE. And they're going to talk about wearing the gloves for shock hazards and everything else. That's just administrative controls. So that's, people are like, well, signs are not really administrative. Well, it is. It's not any of the other three. It's not PPE. It's not substitution, engineering control. It's just administrative control to warn people. And you got to remember, there's different levels of administrative controls. You can start thinking, well, I'd rather have training than this, but this is all administrative controls. So written workplace policies like lockout confined space would be considered an example of administrative controls. A. B. Engineering controls. C. Elimination. D. Personal protective equipment. Now we should be getting pretty good at this. Very good. It is A. Administrative controls. Sometimes, I always recommend a safe lifting number. I finally got to work with one of the largest retailers, and they agreed that they're going to go to 50 pounds maximum lift. Another one of the largest construction companies in the country I work with, they're going to go to a 50-pound lift. UPS uses 70 pounds. The Forest Service started at 70 pounds in 1962. But if we got something that weighs like 60 pounds, you can do a two-person lift. The idea is spread out the weight. That's an administrative control. We're going to go in there and say, okay, this package weighs 60 pounds. But if you've ever had to carry anything up a stairs, this is not really what you want. You really need to think about, can I get a cart to move this, and can I take an elevator up there? Because this is hard. It's an awkward package. You could imagine if she goes backwards, she can trip backwards and have the package on top of her. It is tough. And if you have to go take it down, the person in the right is going to probably fall down the stairs, which is not good. You'd be better off trying to put this on a cart and just take it up one step at a time. This is example where it's good. We're going to try to eliminate one person taking it up, but this is where I run into, like, let's get a cart. Even if it's a cart on the stairs, it's much better than this process. Well, you have to have it on the cart. Yes, you would eliminate the hazard. Yes, if you're still doing the lifting, you still have an administrative control. Personal protective equipment is last. So anything you're wearing to reduce the risk to safety and health, and it's the last line. That means you're going to have some exposure, the lowest level protection, and the least reliable control. What I'm doing is testing out anti-fog goggles. There's several companies that make good anti-fog goggles, because people in the food industry got to clean all the time. The water is in the air, and sometimes it gets hot by the oven. So a lot of materials like safety glasses fog up. And if you're using corrosives, you need goggles. Where would you use corrosives? Anything that has lye, anything that has acid, you got to have goggles, because if it goes over your safety glasses, it's coming right into your eye. So there's several types that we use in PPE. They even got life vests, which is not on this chart, but head protection, eye protection, ear protection, respirators, hand protection, foot protection, and like suit protection, like Tyvek suits and stuff. You might have to know the industry standards for safety glasses, Z87.1. Hard hats are Z89.1. Those are sometimes they ask you those. What is the industry standard for those? I haven't never seen it on the other ones, but you know, yet as we call it. Why is PPE considered the last resort for controlling hazards? A, the workers do not fit in many PPE. Frontline workers are involved in the PPE selection process. B, PPE needs to be constantly replaced. C, PPE does not eliminate the hazard and sometimes introduces them. D, the workers do not want to wear it because it's uncomfortable. Very good. Everybody got C. Good. And like I said, sometimes if you wear a respirator and it is hard to breathe through because you have lung problems, you can create maybe a stress on the heart. Or if the PPE is not fitting, people have fallen out of like harnesses that are too big. So OSHA has been very much this last 2 years talking about the PPE has to fit. We cannot put somebody that's 50 kilograms, 120 pounds in a 2X harness. They can fall out of it. Same thing for equipment that doesn't fit for harnesses, clothing, everything else. It's got to be fit. I'm a big fan of these Type 2 helmets, like over here, in the back here. These are helmets that take away the impact, and they're replacing the hard hat. Nothing in OSHA requires it yet, but I wear it all the time when I go in and I'm exposed to a potential fall hazard or so. The idea is this chin strap, if you fall backwards, is going to stay on. The hard hat or helmet will stay on. And I've had 12 people in 5 years say that it saved their lives. The last person said, I was up on a step ladder, I was diabetic, and I forgot to eat breakfast, and my blood sugar was low, and I fell backwards, and I cracked my head, and I woke up. I was in the ambulance, and people said, oh yeah, you just fell backwards and you cracked your head. There it is, he's alive. Because, if you would have hit the head and no hard hat, or the hard hat flies off, which is very common, then he would have probably been dead. So little things like this can improve a lot of safety. Which control measure focuses on changing the work practices and procedures? A, elimination. B, substitution. C, administrative controls. D, personal protective equipment. What do you think? Very good. Administrative controls. Remember, anytime you see the word work practices, that's an administrative control. And the limitations are, a respirator like this, a half-mask respirator, has what they call an assigned protection factor of 10. You are expected to know that if filtering face piece, the N95, has an assigned protection factor of 10. The half-mask respirator, approved by NIOSH, assigned protection factor of 10. You got to know that. That is one of the questions they might ask on a respirator. But he's in a way too dusty environment. Look at it. He's coated with dust. It's everywhere. You could be over the level of nuisance dust, which would be 5 milligrams per cubic meter. They call it particles not respirable. The chunks are big, but you got to wear something. And that's what we find out. Sometimes, people in silica, when they're cutting it dry, I have a record of 10,000 times over the OSHA limit. This wouldn't even become close to protecting that kind of worker. You'd have to wear SCBA or airline, or really just do it wet or, with ventilation. So according to the general accepted hierarchy of controls, PPE is typically considered the last resort for controlling hazards. However, which circumstances could it be justified to prioritize PPE as the first control to be used? Boy, this is a controversial question. A, budget limitations. C, schedule requirements. C, convenience and comfort of the worker. D, severity and duration of risk exposure. Very good. It is D. Again, a lot of times, if you got to do something that, like clean a gutter, that takes, by putting a ladder up there, and it takes 5 minutes, versus maybe setting an anchorage on a roof that you have to climb and you could fall by taking the 10-15 minutes. You're trading a longer exposure on it. So that's what I mean by duration of risk. Same thing is, if you're I always tell people this is a tough one. You have to make sure the worker's safe. I mean, so you're doing something, and PPE can protect it. If you know your exposure is only going to be about 3 minutes on doing a simple cut on the dry, you're going to be in violation of OSHA, but it would probably protect the worker. So it is used sometimes. Again, that's a controversial question. But the BCSP definitely likes that kind of a question. Impact resistant gloves. I like that on the left. I love them because I was working with one of the largest companies. They have 10,000 employees, 124 injuries in 2022. When we looked at them, 50% were hand injuries. A lot of them were impact. They wear cut resistant gloves, but when we started looking at them, they're moving a hand and it comes up to a fixed object and it gets pinched, and next thing you know, it wasn't hard, but it causes a possible fracture or severe bruising, straining of the area. So now people are going into these impact resistance. There's not really a good ANSI standard on it. I haven't seen anything published by the industry or ASTM, American Society of Testing Materials, about measuring impact resistant. But this company went to okay, you're going to wear the cut resistance all the time on this construction site. If you're handling materials where your hand could get pinched, you're going to pull out these and you're going to wear these gloves. That's good. In the end, 2023, we go from 124 total injuries to 77. That's a big difference. That's a big difference. You're saving millions of dollars by reducing it. But this is what you do when you look at your total injuries. You try to put them by the category and the type. And I was picking up, they were looking at a lot of impact injuries. And so this works out well for a lot of people. What we have on the right is all the saw manufacturers, lathe manufacturers says don't wear gloves anymore. But, if you've been around particles that cut metal or wood slivers, you want some puncture resistance. So this one, you can see, has a cut rating also, but it has some puncture resistance of 1 or so. But they have tear-off fingers, so if it gets caught, these things just pull off, and you wouldn't be able to get caught in the machine and wrap your fingers and shirt in it. It's something you have to evaluate. What is the hazard of a sliver or metal in your finger versus getting your fingers caught? But this is Tillisec, T-E-C at the end. It's something we work with. If we know we're going to have metal parts and stuff, I don't want people getting slivers. I'd rather go in there and set up procedures in PPE. If we can't work behind interlock guards or something. Then the long one. Well, when one of the things when you go in this one, it's tough. When you're doing a 200 question test on most of these, and now you got to read this long one, and you're already tired. So, as a safety professional at a fitness equipment manufacturer, you see there are 4 back injuries this year from lifting boxes of extra size equipment from a conveyor to a pallet. The conveyor is 36 inches high. The pallet is 4 inches high. The pallet is 36 inches from the conveyor. The box weighs 110 pounds. What is the best solution to this problem? Rotate the lifting task so the workers only lift the products 2 hours a day. Lower the conveyor to 28 inches to ensure 2 workers lift the box. Provide the workers with safe lifting training and implement a stretching program. D, provide a vacuum assistless device to lift the box to the pallet. Whew, that's tough. Just the way they rated it. Oh, everybody's already got the answer. It is D, vacuumless. And that's what you want to do, because that's the engineering control. You're not going to lift anymore. And this is what it looks like. I have companies, you're lifting a lot of injuries. And I says, here's a company lifting a 50-pound bag of food. They put one of these in for $12,000, and look at it, no more injuries. They went from 4 injuries. This is a real question, real case. And they loved it, and they go through it. And I'm dealing with the poultry company. Oh, we tried it. Our ceilings are only 9.5 foot high. I says, they got lifts that'll work. I mean, why are you physically lifting crates of 32 pounds over and over and over all day long? To the ground, from the conveyor to the ground. It doesn't make any sense. And then they're stacking them up. They want to go to 6 foot. I says, oh, now we're going to lift this a lot of times. And they can't understand why everybody's getting hurt. I says, that's when the boss needs to do the job for a day, because then you'll realize it's hard. It's physically hard. This you can do while you're just guiding it. It doesn't take any pressure to move around. So summary, you want to choose the controls that are most feasible, effective, and permanent. Any questions? All right, I appreciate everybody taking their Sunday to come out. I'm going to put this on YouTube, and then you'll be able to view it later and review it